Now we're going to solve systems of equations by substitution. All right, so again, this is a page. I don't recommend that you write these down verbatim, but if you want to take some notes, that is totally fine. I'm going to show you these steps, and I think after a few examples, you'll have these down anyway. So maybe just read over them and don't necessarily write them down unless you feel like later you need to come back to it. All right, so again, you learned from the last lesson that what we are looking for is we are looking to see that place where these two lines cross each other, right? We are looking for that point of intersection, okay? And that happens a lot, but sometimes we learned from the last lesson too that sometimes we get parallel lines. And then sometimes we get lines that are the exact same line and they sit on top of each other, right? Okay, so we're looking for that today. All right, the first thing that I would do if I were looking at these and trying to figure out what to do, and I was going to do this without graphing, is I always take a look at the X and the Y and the X and the Y, okay? And I ask myself, is there one of these variables that can easily be solved for itself, okay? So what that means is there one of these X's or Y's that I could easily make all by itself on one side of the equal sign, okay? And to tell you the truth, this one or this one would work, okay? It doesn't really matter which one you choose. So I'm going to take this top one, okay, and I'm going to solve it for Y. I'm going to get the Y all by itself, all right? So, oops, I keep doing that. So again, I'm solving for Y. I'm getting the Y all alone. Now, check this out. All right, so I could take this information right here because it says that this is what Y is equal to, and I can put it in, substitute it in for Y into the second equation. And I want you to see what happens. This is actually kind of cool. All right, so I'm rewriting the second equation, but instead of Y, I'm no longer writing Y, I'm going to write what Y equals. Okay? Now, one thing I want you to see here is notice we don't have a Y anymore. We have an X, only an X in this equation, right? And when you're down to only one variable, guess what you can do? You can solve for that variable, okay? So we're going to distribute now. Now I'm going to combine my like terms. I'm going to move my 14. And divide by 5. Check that out. X is 4. So we have half of our ordered pair here. Let's look for the other half. Now, there's a couple of things we can do. We can take this 4 and we can put it in either there or there, okay? Now, could you put it in right here? Yeah, you totally could. But my recommendation is, what if you made a mistake right here? If you substitute a value into an equation that you made a mistake on, you're going to get out a number. It's just going to be the wrong number, okay? So that's one way to kind of catch yourself if you made a mistake right here, is to take the number you get and put it into one of the original equations, okay? Go back to the original equation, and then you should check your work at the very end. All right, so I'm going to put the 4 in. I could either put it here or I could put it here, and I think this looks like the easiest one to put it into, so that's what I'm going to do. I keep doing that. So in order to solve for Y, I would subtract 4 and then divide by -2. And so there's our Y. So this right here is our solution. Now, can you check your work? Yes. And how many times do you have to check it? Remember, twice. You have to check it twice. Okay, so we're going to do that. Just on this problem, I'm not going to do it throughout this video for the sake of time, but I am going to do it on this problem. Okay, so I'm going to write the solution again right here. And we've got 2x plus y equals 7. And then on the other one, we have x minus 2y equals 6. All right, so we're going to see if this really is our solution by checking our work. Ooh, I don't know if I have enough space to do this, but we'll try. So 8 minus 1 equals 7. Yep, 7 equals 7 today. That's good. Okay, so now we're going to substitute it in over here. 4 minus 2 times negative 1. This is really 4 plus 2. Yep, that works too. Okay, I am sure with 100% certainty that this is our correct answer. Okay, do you remember earlier whenever I said we could either solve for this y or we could solve for this x and we should get the same answer? Okay, this is the only problem I'm going to do this with. I'm not going to waste your time any other time, but we know that this is the correct answer. By the way, if you don't want to see this, then just kind of fast forward through this part. But what I'm going to show you is, what if we hadn't solved for the y right here? What if we had solved for the x? Would we still get the same answer? And that answer is 100% yes. Okay, and let me show you. Let me erase. Okay, sorry, I was wasting your time. Okay, so again, what I'm going to do is I'm going to solve for x instead of y this time. So I've got x minus 2y equals 6. I would add 2y to both sides. So I get x is equal to 2y plus 6. Now, what you want to do here, since we solved for x in the second one, is we want to take what x is equal to, and we're going to put it in for x in the other equation, okay? So I'm going to put it in right here. All right, let's do that. I keep doing that. Now, instead of x, I'm going to write 2y plus 6 plus y equals 7. Notice I rewrote the first equation, but instead of x, I put in what x was equal to, okay, from the second equation. Now, we're going to distribute. And I'm going to combine my like terms. Subtract 12. And divide by 5. Look at that. We got our y is negative 1. Okay, so now we would take this information and we would put it into one of our original equations. It does not matter which one. I'm going to put it in the second one. All right, so I've got x minus 2 times negative 1 equals 6. X plus 2 equals 6. Subtract 2. X is equal to 4. Look at that. Okay, so we still got the exact same answer. So my recommendation is, using the substitution method, find one of the variables, if there is one. There's not always a variable that doesn't have a coefficient, but if there is one of them that doesn't have a coefficient, solve for that variable. It makes your life easier. All right, so let's look at this example. Notice we already have y solved for us. We don't need to change the format of this to substitute this information in for y right there. Okay, so that's what's beautiful about this problem. This one will go a lot faster than the last one. So I'm going to take this information and I'm going to substitute it in for y right there. Okay, all right, so I'm rewriting the first equation, but instead of y, I'm going to put x plus 5. And now we can solve for x. And divide by 2. So we have x is equal to negative 3. Okay? Now, we have our first piece of this ordered pair, so let's look for the second. So I'm going to take this information and I'm going to put it in for x. I could put it in there or there. The second one looks a little bit easier though. So y is equal to -3 plus 5. So y is equal to 2. There we go. There's our solution. And I hope that by now every single person knows how to check their work. All right, so let's solve this one by substitution. Notice both of the equations are in standard form. Which of these variables, there's this one, this one, this one, and this one, which of them would be the easiest for us to solve for so that we can substitute that into the other equation? Well, check this out. This one has a coefficient, this one has a coefficient, this one has a coefficient. This one is going to be our easiest variable to solve for because it has 1 as a coefficient, okay? And 1 as a coefficient is actually what we're looking for. So I'm going to take this first equation and I'm going to subtract 3x. Okay, now that we have y solved, we can take this information and put it in for y right there. Okay, so now I'm going to take that and rewrite the second equation. Okay, notice my y's went away. That's good. That's what we want. And I want to distribute so that we can solve for x. Oops, that's going to be a minus, isn't it? Combine my like terms. And divide by -10. So x is equal to +3. Okay, now to find our y, again, don't go back to the equation that you made. You can, and you'll still get the right answer if you've done everything correctly. But if you haven't, if you've made a mistake somewhere in here, it's easy to keep making a mistake, okay? So what my recommendation is, take this 3 and put it back into one of the original problems, okay? Go back to the originals. All right. So I'm going to go back to, let's say, the top one. So instead of x, I'm going to write 3. There we go. There's our solution. And yes, you can check your work. I strongly recommend that you always check your work on these problems. There is no reason to miss these problems if you can always check your work. All right, so here we go again. Now, again, take a look at your coefficients. Which one of them, if any, have a 1 as a coefficient? Well, it's this x right here, right? That's going to be our easiest one to solve for. So you would add 2y. So x is equal to 2y minus 2, okay? So now I can take what x is equal to, and I can go to the second equation, the other equation, and put that in right there. Okay, so here goes. So now instead of x, I'm going to write 2y minus 2. And I'm going to finish rewriting the second equation. Now I'm going to distribute and solve for y. Combine my like terms. Add 6. and divide by 8. So we've got our y is 5, okay? Now, we need to find our x though, right? So let's take this 5 and let's put it in for y, either there or there. It doesn't matter. I think the top one looks like the easiest one. So x minus 10 equals -2. Add 10. X is equal to 8. Okay, again, spot check at least. So here's what I do. Like in my head, I'll go, okay, x is 8. 8 minus 10, that is -2. Okay, so then right here, I would substitute just in my head. I'm doing this in my head. I'm checking in my head. 3 times 8 is 24. Plus 10 is 34. Yes, that's right. Okay, I feel very certain that this is our correct answer. All right, so look at this. These are, they're both in slope-intercept form, which is actually also kind of nice. So check this out. I can take this business right here and substitute it in where I see y in the other equation. So I've got 1/2 x is equal to -2x plus 5. Okay, get our x's together on one side. If I move this one to the right, have I not just moved everything over to the right? I don't want that. I want my variables on one side and my constant term on the other side of the equal sign, right? So I would actually add 2x here. And what is 2x plus 1/2 x? Well, it's 2.5 x, right? So that would be what? 5/2 x. And then divide both sides by 5/2. What is 5/1 divided by 5/2? Keep, change, flip. X is equal to 2. Okay? All right, if you guys are not good at doing fractions like that, grab a calculator. I cannot tell you enough. You can make it through math and or algebra anyway, and not be the best with fractions. Just make sure you're checking your work on a calculator. Everybody makes mistakes. Everybody. Okay? So now let's find what y is. So y is equal to 1/2. I'm using the bottom one times 2 because it looks like the easiest. 1/2 of 2 is 1. So our ordered pair is 2, 1. Okay, again, I would check my work in my head. So let's see here. 1 is equal to, this would be -4 plus 5. Yep, 1 is equal to 1. 1 is equal to 1/2 of 2, which is 1. Yes. Okay, so I feel certain that this is the correct answer. All right, so again, let's take a look. Coefficient, 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 that's a -1. So it just adds one little extra step. So we are going to solve for this y right here, but we're going to have to do one little extra step to get rid of the negative sign. So 6x minus y is equal to 8. We're going to solve for this y right here. And now I have to just divide everything by -1, which just changes the sign. That's all it does. So this is what I'm using for y into the first equation. Remember, you go to the other equation, okay? So now I'm rewriting the first equation. And instead of y, I'm going to put 6x minus 8. So now I'm going to distribute. Combine my like terms. Move my constant over to the other side. And divide by 16. So x is equal to 5/4. And that's okay. It's okay to have a fraction as an answer. It just kind of makes it kind of a pain in the rear to find the other one. Okay, so now I want to take this 5/4 and I want to put it in for x either there or there. Let me tell you why I'm choosing the top one. Let me erase this little box right here. I am choosing this one because I can get rid of the fraction with this 4. Notice this 4 and this 4. Whenever I multiply this times this, the 4's will cancel. Okay? That makes my life just a little bit easier. All right, I'm always looking for places where I can make things easier. And it's just one less place to make a mistake. So 4 times 5/4. Sorry, you can hear my dog walking around. She's getting her nails clipped today. Hi there. Okay, so the 4's cancel. Subtract 5 from both sides. And then divide by 2. Just because we canceled that fraction doesn't mean we won't end up with a fraction, okay? So there we go. We've got y is equal to -1/2. Now, let me tell you, would I still check my work? Absolutely, especially since I have fractional answers. Not that they aren't possible, it's just, it's very easy to make a mistake, okay? But here's what I would do. I would grab my calculator and I would type this in. So here's what I'm typing in. I'm going to type in 4, then I'm going to hit times 5/4, and my calculator does fractions. If you don't have one that does fractions, you should get one, and I've got it in the syllabus, the one I recommend. And then I hit plus 2 times, and now I'm going to type in -1/2. And then I'm going to hit equals. Now, when I hit equals, what am I hoping to get? I'm hoping I get 4. If I get 4, I know that I've done this right. Oh, yeah, I did. I got 4. Okay, but remember, you also have to check the other one, okay? So I'm typing in 6 times 5/4 minus -1/2. And what am I hoping to get? I'm hoping to get 8, right, when I hit enter? And I do, okay? So I feel 100% certain this is the correct answer. Okay, so what if you have two equations and none of them have a 1 as a coefficient? Okay, this is one of those cases where after the next video, you'll see what I actually prefer. But since this is a video on substitution, I'm going to go ahead and show you how to do this, okay? Now, you have to decide, am I going to solve for x or am I going to solve for y? And I'm going to tell you right now, it doesn't matter, okay? I'm going to solve for x because I've chosen the x in the top because, number one, these numbers are smaller. I like dealing with smaller numbers. Could I deal with these in the denominator or in the bottom equation? Yeah, totally. But I like dealing with smaller numbers. I tend to make fewer mistakes in my head that way. All right. The other thing, too, I chose the x because the y has that extra step of a negative sign, and we all know how all of us are bad with the negative sign sometimes, right? Okay, so let's solve for x in that first equation. And then divide every single term by 4, and reduce when you can. Okay, so this is what x is equal to. So I can take this information and I can put it in for x in the other equation. Okay, that's what we're going to do next. All right, so I've got 15y minus 20. Now instead of x, I'm going to type in or write down 3/4 y plus 3/2 equals -30. Okay. Now I'm going to distribute my -20. Now, here's my fast way. Here's how I do fractions the fast way. So 4 goes into 20 how many times? And by the way, is this going to be a positive or a negative? It's going to be a negative, right? So negative times a positive is a negative. So I'm going to go ahead and write that so I don't forget it. 4 goes into 25 times. 5 times 3 is 15. Okay? Then negative 20 times 3 halves. So I know it's going to be a negative because a negative times a positive is a negative. So I'm going to write that down. 2 goes into 20 10 times. 10 times 3 is 30. Okay, look what happens. What is 15y minus 15y? It's 0, isn't it? It goes away. You're left with negative 30 equals negative 30. Okay, is this a true statement? Does negative 30 actually equal negative 30? The answer is yes, that is a true statement. Guess what? When your variables go away like this, and you're left with a true statement, that means that these lines have the exact same slope and they have the exact same y-intercept. Let me show you. We already solved for the, no we didn't. We solved for y or x. So let me show you. And then divide by negative 3. So you've got y is equal to 4/3 x minus 2. Check this out. I'm going to do the same thing for the bottom equation. I'm going to solve for y, get it in slope-intercept form, and I'm going to prove to you that they have the same slope and the same y-intercept. Divide everything by 15. So y is equal to 4 goes into, nope, I don't want that. 5, sorry. I don't know, I'm losing my mind. 5 goes in, there's 4/3, there we go, minus 2. Oh, I forgot my x. There we go. Okay, compare your slopes. They're both 4/3. They have the same y-intercept. So same slope, same y-intercept means that these two equations, their lines sit on top of each other. And how many solutions is that whenever you have two lines that sit on top of each other? Remember that answer is infinitely many solutions. So when you're using substitution, what'll happen is your variables will die, like they'll go away. And then you're left with a true statement. What'll happen if you have a parallel line, two parallel lines, what'll happen is your variables will go away, but you're left with a false statement. So you won't get two numbers that actually equal each other. Okay, and I'm thinking that's probably the next example. All right, so check this out. So we've already got a y that's solved for us, right? So I can take this information and I can put it in for y right there. Okay, so I'm rewriting the top equation, but instead of y, I'm putting in 5/2 x. Okay, so now the 2's cancel. So I've got 5x minus 5x is equal to negative 10. Well, 5x minus 5x is 0. Does 0 equal negative 10 today? Not today. So this is a false statement. It is never possible for 0 to equal negative 10. A lot of times this is where I get questions from students. They're like, I think I did my math wrong. And I'm like, no. The equations are trying to tell you that you actually have some parallel lines here. You came up with something that is just ridiculous. And you didn't do your math wrong, okay? So this means that there are no solutions. These two lines are parallel. That means that they have the same slope, but different y-intercepts. All right, and these are just some suggestions for solving applications. Again, not something I really expect you to write down and memorize, but you just might want to read through it and just, if you're having troubles with these, go back to this and maybe it'll help you solve it. All right, so the sum of two numbers is 0. One number is 9 less than the other. Find the numbers. Okay, so we always start off by identifying our variables. So let x equal the first number. Okay, I'm going to let y equal the second number. And I know that one number is 9 less than the other. So let's say that y is equal to x minus 9. Okay, because one of them is smaller than the other, right? It says here that the sum is 0. So x plus y equals 0, right? Now, remember, look, I created this right here. So that means I can take this information and substitute it in for y right there. So I'm rewriting this equation. Now instead of y, I'm going to put x minus 9. Combine my like terms. Add 9. Divide by 2. And I can leave it either as 9 halves or 4 1/2. Okay? 9 halves is the same thing as 4 1/2. Now, how do I find my other number? Okay, if one of them is 9 halves, the other one is 9 less, right? So I would substitute this information in right here. Okay, so I've got y is equal to 9 halves minus 9. And if you're doing this on a calculator, you're done by now. If you're not doing this by calculator, that's how you do that. All right, so negative 9 halves is the other number. Does that make sense though? Yeah, it totally does. So sometimes it helps to put these as decimals. So let's see here, negative 4.5 and positive 4.5. Are they 9 away from each other? Yeah, totally. On a number line, there's 0, 1, 2, 3, 4, 5. So the positive one is over here. Pardon me for not making those even. The negative one is over here. Yeah, those are 9 away from each other, okay? The other thing too, whenever you add them together, do they create, 0? Yeah, they do. Positive 4 1/2 plus negative 4 1/2 equals 0. That is correct. Okay, so the two numbers are 9 over 2 and negative 9 over 2. All right, so for this one, perimeter of a rectangle. First of all, you need to know what a rectangle is, which I think everybody probably does. And you need to know how to find the perimeter. The perimeter of any figure is you just add up all the sides, right? But on a rectangle, if you have, this is your length and this is your width, your perimeter is equal to 2 times your length plus 2 times your width, okay? So we know that the perimeter is 88. So I can put 88 into this equation, okay? The second equation, the length is 5 times more than the width. So I'm just going to write it in algebraically the exact way that it's written here. Length is 5 more than twice the width, okay? So guess what? I've already got a variable solved for me, so I can take this and I can put it in for L right there. So I'm rewriting this one. So I've got 88 is equal to, and now instead of L, I'm going to put 5 plus 2W. That's a W. I don't know what's wrong with me. Okay. So 88 is equal to 10 plus 4W plus 2W. Combine your like terms. Subtract 10. And divide by 6. And so W is equal to 13. Okay, now to find our length, we are allowed to take this 13 and we can put it in either right there or we could put it in right there. This one will be easier to solve. So let's do that. So my length is equal to 5 plus 2 times 13. Now, what I would do if I were you is I would do 2 times 31 plus 2 times 13 on a calculator. And what are you hoping to get out? 88, okay? So 2 times 31 plus 2 times 13, and I hope I get 88, and I just did, okay? I can also check it here. I would say 31 is equal to 5 plus 2 times 13, okay? And you should get 31 there. All right. All right, the measure of one of the small angles of a right triangle is 10 more than 3 times the measure of the other small angle. Find the measure of both angles. So this gives us a lot of information right here. It's a right triangle. That means there has to be a right angle in it, okay? So we know, let x equal one of the small angles, and we're going to let y equal the other. All right, so this one's our right angle, which we know is 90, okay? Now, it says here, one of the small angles is 10 more. So let's say y is equal to, it doesn't matter, you could put x there. Y is equal to 10 more than 3 times the measure of the other one, okay? All right, so we have this equation right here. Now, the other thing that we have is we know that x plus y plus 90 is equal to 180 because the angle measures of a right triangle, or any triangle in this case, add up to be 180 degrees. Okay, so I can take this information and put it in for y right there, okay? So x plus, instead of y, I'm going to write 10 plus 3x plus 90 equals 180. I'm going to combine my like terms. So I get 4x plus 100 is equal to 180. Subtract 100. 4x is equal to 80. Divide by 4. So x is equal to 20. Okay, now to find the other one, I can either substitute this 20 in right here, or I could put it in right here. And honestly, this one is your easiest one. It's shorter. So, my dog is over here snoring. I don't know if you can hear her or not. She had kind of a rough day yesterday. She's prone to seizures, and she had a really big one, so. All right, so y is equal to 10 plus 3 times 20. So y is equal to 10 plus 60. So y is equal to 70, okay? So what we need to make sure is that the 3 angles add up to be 180. So 70 plus 20 is 90. Plus 90 is the right angle, is 180. That's true. Okay, so I feel pretty certain that we do have the correct answer. 70 degrees, 20 degrees, and 90 degrees are the 3 angles, but they don't care about the 90. They say just both angles. So really all we care about are these two. 20 degrees and 70 degrees. All right, so for this problem, Heather has been offered 2 options for her salary as a trainer at the gym. Option A would pay her $25,000 plus $15 for each training session. Option B would pay her $10,000 plus $40 for each training session. How many training sessions would make the salary options equal? Okay, so the 2 things that we're dealing with, we're going to let x, our independent variable, be the number of training sessions. And y is going to be our total salary. Okay, so with option A, our equation would be y is equal to 15 times the number of training sessions plus $25,000. With option B, her salary would be y is equal to, let's see here, 40 times the number of training sessions plus $10,000. Okay, now watch this. Oops. This right here, because y is equal to that, can be placed right there. Okay, so I'm rewriting this top one, but instead of y, I'm putting 40x plus $10,000. And what I'm finding is I'm actually finding the total solution. They didn't ask what her total salary would be. They asked how many training sessions, and that's what I'm solving for in this case, okay? So subtract 15x from both sides. I get 25x plus 10,000 is equal to 25,000. And then subtract, not divide. So 25x is equal to 15,000. Divide by 25. 15,000 divided by 25 is 600. Whew! She would have to do 600 training sessions for these salaries to be equal to each other. Okay? Let's see here. This is an annual salary. So this is 600 training sessions in a year. So divide that by 12. That's how many she could do. That's 50 per month. So she needs to think about, is 50 per month an attainable goal? If so, if she could do more than 600, I would take option B because she gets paid more for the training sessions. If she thinks that she can't do 600 a year, then option A would actually pay her more. So just something she needs to think about. All right, so this is it for this video. If you have any questions, don't hesitate to reach out.